equal to 1 by 1 plus s. For the input RT equal to sin t, a steady state value of Ct is equal to. The four alternatives are given, and this question has been asked in GATE 1996. So the transfer function is means Ch divided by Rs. This is given as 1 by 1 plus s. Now input, since input is sinusoidal input, this is sinusoidal input. So, and it is asking about a steady state value of Ct. So since input is sinusoidal and omega is, since omega is 1, here omega is 1, because sin omega t means here omega is 1. It is given that here we should write given that, also it is given that RT input is, this is equal to sin t. That means omega is equal to 1 radian per second. Now if we replace this s by j omega, then how much it will give? Then Cj omega by Cj omega, this will be equal to 1 by 1 plus j multiplied by RT. So how much it will come? 1 by 1 plus j, it will come, what will be its magnitude? Its magnitude will be, we can write here as 1 minus j into 1 plus j multiplied by, or in phasor form, 1 by 1 plus j can be written as, this can be written as the magnitude is magnitude of 1 by under root 1 plus 1. So it is 1 by root 2. And what is the angle? Angle is of 1 plus 1 by j. This will be equal to minus tan inverse 1, because j is 1 and 1 is 1. So minus pi by 4. So from here, now from here, Ct, we can write Ct will be equal to, this will be equal to 1 by root 2 angle minus pi by 4, and this is nothing but sin t. So that will be equal to 1 by root 2 sin t minus pi by 4, because this term is responsible for a magnitude of 1 by root 2 and a phase angle lag of pi by 4. So it will be 1 by root 2 sin t minus pi by 4. So which should be the correct option? So the correct option will be D. Into s plus 2 into s plus 3, the Nyquist plot of G in circle's origin. There are 4 options given, and this question has been asked in GATE 1992. So according to the principle of mathematical argument, the Nyquist plot, a unity feedback system has the open loop transfer function. The Nyquist plot of G in circles. The Nyquist plot of G. It is asking about the Nyquist plot of G. So the Nyquist plot of G is having no zero. It is having only one pole. It is having only one pole in the right half of S plane, because these two poles are in left half of S plane. So let me see whether this system is stable or not. So whether this closed loop system is stable or not. So let me write the characteristic equation for the closed loop system. So the characteristic equation is equation for closed loop system is 1 plus gs equal to 0, because here it is unity feedback. So what will be 1 plus 1 by s minus 1 into s plus 2 into s plus 3, this equal to 0. Now this will be equal to s minus 1, s plus 2, s plus 3, here s minus 1, s plus 2, s plus 3. Plus 1. So s minus 1 into s plus 2 into s plus 3 plus 1 equal to 0. Now this will be s square plus 5s plus 6 plus 1 equal to 0. Now if we calculate, this will be s cube plus 5 s square plus 6s minus s square minus 5s minus 6 plus 1 equal to 0. This implies s cube plus 5 s square. So here it will be 4s square, because this s square will be subtracted from 5s square plus s minus 5 equal to 0. So this is the characteristic equation of the system. So if we apply Rao's stability criteria, then it will be Rao's array will be s cube here and here s square. So this one, because the coefficient of s cube is 1 and alternate coefficients are written here. Here coefficient of s square is 4 and coefficient of s to the power 0 is minus 5. Again s to the power 1 will be how we will do? We have to multiply this 4 by 1 minus this 1 by 5 divided by 4. So here we can write 4 multiplied by 1, 4 multiplied by 1 minus this 1 multiplied by minus 5 divided by 4. So how much it will come? 1 plus 5. So it will be 9 by 4. So it will be 9 by 4. Now s to the power 0 will be how we will calculate? 9 by 4 will be multiplied by this 5, and again here 4 will be multiplied by this 4 will be multiplied by, here there is nothing but nothing, so it is 0 divided by this 9 by 4. So it will be 9 by 4 multiplied by minus 5 minus 4 multiplied by 0 divided by 9 by 4. So it will be minus 5. So it will be minus 5. So from here we can see that the system is unstable. The closed loop system is unstable because there is one sign change here. Here one sign change takes place. Here one sign change is taking place. Sign change. So there is one sign change in, I should write, if the system would be stable, then the point -1 plus j into 0 will be encircled once in anti-clockwise direction, since one open loop pole of is lying in right half of the sphere. Since one open loop pole is lying in right half of the sphere. But this would be possible when the system is stable. But here the system is unstable. Since the system is unstable, so the point -1 plus j into 0 will be, and the system is unstable, and one pole of closed loop system is lying in right half of the sphere. One pole of closed loop system means 1 0 of GA1 plus GS is lying in right half of the sphere. So the point -1 plus j0 will be encircled one time in clockwise direction. Since this, but the closed loop system is unstable with one closed loop pole in right half of S plane. So the point -1 plus j0, so this will so due to this the point -1 plus j0 will be encircled once in clockwise direction, since the pole of closed loop system is nothing but zero characteristic equation. Pole of closed loop system is nothing but 0 of 1 plus GS equal to 0. So if we see these two criteria, means this open loop pole is responsible for one anti-clockwise encirclement of point -1 plus j0. But since the system is unstable, so it is responsible for one clockwise encirclement here. Encircled once in clockwise direction, and here encircled once in anti-clockwise direction. So the net encirclement, if we see these two points, then the net encirclement will be 0. So the net encirclement, from here we can conclude that net encirclement will be 0. Of point means there is no encirclement. So if there is no encirclement of minus 1 plus j into 0, that means there will be no encirclement of point origin also. So it will be never encircled. So never encircled. Actually, in the question, the Nyquist plot of G encircles the origin. In place of origin, it must be in place of origin. It must be the point minus 1 plus j0. Then the question will be more accurate. Otherwise, the question should be the encirclement of the not Nyquist plot of G. There should be the Nyquist. There should be the plot of this. The plot of this in UV plane only. The plot of this only. Then the question will be correct. So the question is confusing here. But if we take the encirclement of point this, then it will be never encircled. The system having the body magnitude plot shown in figure below has a transfer function. There are 4 alternatives given, and this question has been asked in GATE 1991. Again, we see that this body plot is existing before 1. Or you can say left to 1. So since it is existing left to 1, and again it is existing left to 0.05, 0.1 also, so there must be some open loop, you can say open loop pole at origin, because if there is no open loop pole, then this should stop. This should stop here only, because at 0.05, let me indicate this. This is the point. This is the 0.05. 0.05. This is a corner frequency. Again, this point 0.1 is a corner frequency. But left to this corner frequency also, this is the plot is existing. That means there is some pole at origin. So what is that pole? So that pole is, since before that the slope is minus 20 dB per decade, so it only means there is only one pole at origin. So the transfer function will be Ts equal to, let me write some constant k divided by s. Again here the slope changes and it becomes minus 22, it becomes minus 40, and again it becomes minus 20. So since it becomes minus 40, from minus 20 to minus 40, so there must be a, since it is downgrading, that's why I am saying that it is changing from minus 20 to minus 40. Again it is getting parallel to this one, then it is again here the slope is again minus 20 dB per decade. So here the slope must be, minus 40 dB per decade, and here the slope must be again minus 20 dB per decade. So here there will be a pole which is responsible for again the decrease in slope with 20 dB per decade, because this slope is 20 dB per decade again, and after that the slope is minus 40 dB per decade. So there exists a decrease in slope of minus 20 of 20 dB per decade. So there must be a pole here with corner frequency 0.05. So we should write here 1 plus s by 0.05. Again here the slope is again becoming minus 20 dB per decade. So slope is increasing. So there must be a 0 with corner frequency 0.1 here. That's why the slope is increasing. So this will be 0 will be 1 plus s by 0.1. So now we are left to evaluate what is the value of k. Here we can say it is 60 dB, and here it is 0.1. So here it is 0.1. So this one, then this value is responsible. This uplift of this value is responsible for, or this k is responsible for this value, because if there is no pole at with corner frequency 0.05, and if there is no 0 with corner frequency 0.1, then this line will pass. Then this line will pass through this line will pass like that. So at omega equal to 1, this line will not pass through omega equal to 1. This line will pass through here, this point. So this much uplift is due to this k only. So now we have to calculate this k. So this uplift is due to 20. This uplift is due to 20 log k. So this 20 log k is only responsible for this much uplift. Now we have to calculate how much is the value of this. Now what is the value of this? Is 60. So from 0.01 to 1 it is 1 decade, and from 0.1 to 1 this is 0.1. This is 0.1. Let me write here. This is 0.1 clearly. So from 0.01 to 1 it is 1 decade. From 0.1 to 1 it is another 1 decade. So it is 2 decade. So it is 2 decade. Let me clearly write here. This is 100. It is 100. So it is 2 decade. So if this is 60 dB, so and this slope is minus 20 dB per decade. So if this line is extended, then what will be the value? What will be the drop? This drop, if we write this like, so what will be, how much will be this drop? So this drop will be nothing but, since this is 2 decade, this one is 2 decade. From here to here it is 2 decade, because 0.01 to 1, 0.01 to 1 decade, and 0.1 to 1 decade. So this one is 2 decade. From here to here it is 2 decade. So, and the slope is minus 20 dB per decade. So this drop would be minus 20 multiplied by 2. So it would be 40 dB. So it would be 40 dB. So it would be 40 dB. So this will be 40 dB. Now if this is 40 dB, then this will be 20 dB only. So this will be only 20 dB. Only 20 dB. So this 20 dB uplift, the uplift of 20 dB is due to this 20 log k. So now we can write here this 20 log k equal to 20. This means this 20 will cancel out each other, k equal to 10. Now the transfer function Ts, we can write transfer function Ts as equal to 10 multiplied by 1 plus s by 0.1 divided by s into 1 plus this will be 20 s. This should be 1 plus 10s. Okay. So 10 multiplied by 1 plus 10s divided by s into 20s plus 1. So option number B is correct one. Next question is, which of the following is the transfer function of a system having the Nyquist plot shown in figure below? This is the Nyquist plot shown and 4 alternatives are given, and this question has been asked in GATE 1991. So let us see which alternative is correct one. Let us draw the polar plot first. The polar plot is so this one is the polar plot. This is omega equal to 0 and this is omega equal to infinity. So this is the polar plot. Now the polar plot starts from angle minus 180 degree and terminate at angle minus 360 degree. So since the polar plot starts from infinity at an angle minus 180 degree at omega equal to 0. Hence, the number of poles at origin will be equal to minus 180 degree divided by minus 90 degree. That will be 2. Again, second point is the polar plot terminates at angle minus 360 degree at omega equal to infinity. Again, the polar plot terminates at an angle minus 360 degree at omega equal to infinity. Hence, the difference between zeros and poles and zeros are minus 360 degree divided by minus 90 degree. So it will be 4. So these are the 2 points. Means the open loop poles at origin must be 2 and the number of poles, the difference between number of poles and zeros must be 4. So let us see which one is the correct one. Here total number of poles are poles at origin 2. Since poles at origin are 2, so only B, C and D can be correct. So but number of poles, the difference of poles and zeros are 4. So here not 4, here not 4, only B option is correct. So option number B is correct. Now at the last of the lecture, I would like to share one of the most important thing to you people, that if you like my video, then you must subscribe my video, so that there is no need to search out new video. Automatic update will come if I upload the new videos what you have to do, it is very simple. There is a circular logo coming in right of me. You have to just click on that to subscribe.